Problem number 9. So here we have the differential equation y times the second derivative of x with respect to y equals y squared plus 1. So clearly it involves a second order derivative. So the order of the differential equation is going to be equals to 2, and if we look at the degree of the highest order differential, so that is 1, so the degree is going to be 1. Now, in order to determine the linearity, we have to simplify this given differential equation. For that, we are going to divide both sides of the equation with y. That will give us second derivative of x with respect to y is equals to y plus 1 over y. Now, we are going to compare it with the standard polynomial form of a differential equation, of a linear differential equation. So, we have the coefficient a2 of y times second derivative of x with respect to y plus a1 of y times the first derivative of x with respect to y plus a0 of y equals to 0. Now when we compare, we clearly see that the constant coefficient a0 y is equals to negative of y plus 1 over y, which is a function of y. And because of that, we can clearly say that this differential equation is a linear differential equation. Problem number 10. S squared multiplied to the second derivative of t with respect to x plus st times first derivative of t with respect to s is equals to s. If we look at this differential equation, we can clearly see that the highest order differential coefficient is second derivative of t with respect to x, so the order is going to be equals to 2, and the degree will be 1 because that is the highest power of the highest order derivative. Now coming to the linearity, this is going to be a non-linear differential equation because if we look at the coefficient of the second term, so that is s times t, this is clearly a function of s and t, where it should have been a function of only s if it were to be a linear differential equation. Hence, this is a non-linear differential equation. Problem number 11. X squared multiplied to second derivative of y with respect to x cubed plus y times first derivative of y with respect to x raised to the power of 4 plus y raised to the power of 4 equals to 0. If we look at this differential equation, the highest order differential coefficient present is the second derivative of y with respect to x, so the order is going to be equals to 2, and the degree that follows it is going to be equals to 3. It is going to be a nonlinear differential equation. Number 12. The third derivative of y with respect to x plus the second derivative of y with respect to x raised to the power of 3 plus the first derivative of y with respect to x plus 4 times y is equals to sine x. Here the highest order differential coefficient present is the second derivative of y with respect to x, so the order is going to be equals to 3. It has a power of 1, so the degree is equals to 1, and this is going to be a nonlinear differential equation because if we look at the second term, we have a cubic differential present.